term ionic radius refers to the size of an ion, how big an ion is. In a previous lesson, we used the term atomic radius, which meant the size of an atom. Well, when an atom gains or loses electrons, it becomes an ion. And when it does so, its size changes. It gets bigger or it gets smaller, depending on what it does with electrons. Let's tackle anions first. Anions, as you recall, are negatively charged ions. And the reason they're negatively charged is because they've gained one or more electrons. So let's use chlorine as an example. A chlorine atom, we can look up from the periodic table, has 17 protons in its nucleus. And when we use the term atom, it's implied that the number of electrons equals the number of protons. So a chlorine atom has 17 electrons. So a chlorine atom has 17 protons and some number of neutrons in its nucleus, and its very tiny nucleus, and it has 17 electrons orbiting around the nucleus. So it's a certain size. If we look at a chloride ion has 17 protons, but a chloride ion has gained one electron. It has 18 electrons. And again, you can see this from the periodic table, that chlorine would want to gain one electron so that it could have the same number of electrons as the nearest noble gas, which is argon. So now we have, with a chloride ion, we have 18 electrons buzzing around the nucleus, repelling each other because they're all negatively charged, as compared to a chlorine atom, which has only 17 electrons. And so it turns out that a chloride ion is larger than a chlorine atom. And this is true generally for anions. The anion is going to be larger. It's going to take up more space than the parent atom from which it's derived. And the more electrons an anion gains, the bigger it gets. So, why is it that anions are larger than parent atoms? The number of protons hasn't changed, so it has the same interior pull from the nucleus, but there's more electron-electron repulsion. So the electron cloud foofs out, if you will. Now let's tackle cations. Cations are positively charged because they've lost one or more electrons. Let's use iron as an example. From the periodic table, iron, we can see, has 26 protons, and an iron atom has also 26 electrons. So, an iron atom is a certain size. When Fe becomes Fe2+, what's happened is the protons have stayed the same, but it's lost 2 electrons. Perhaps there are 2 chlorine atoms nearby, and each of them took one of those electrons. We just talked on the previous slide how chlorine would want to take electrons. Well, maybe chlorine got its electron from iron. In any case, because there are fewer electrons, they're not going to repel each other as much, and the size of that electron cloud is going to shrink. And for Fe3+, we've lost an additional electron, so that we're down to 23, and Fe3+ is smaller yet. So, why is it that cations are smaller than parent atoms? Well, they have the same number of protons as parent atoms, so there's the same pull towards the center from the nucleus, but there's less electron-electron repulsion. So let's summarize what we've talked about here with periodicity trend number 5. This is a statement that can be read twice. You have to read it first with the bold-faced capital letters, and then you start back at the beginning and you read it again with the italicized, boxed-in letters. So let's do the bold-faced capital letters first. Anions are larger than parent atoms, and the more electrons they gain, the larger they get. Now let's read it again using the cations. Cations are smaller than parent atoms, and the more electrons they lose, the smaller they get.